Again, some of your homework problems tonight will have ones where it's asking, could this be the graph of, say, y equals x cubed? And if it, for example, there's 5 turning points, that can't be. Stop and check out questions on that. Just a short, small in-class investigation there. Okay, let's take a look at one. Review of just translations. When we're translating functions, we've been doing this throughout the book, we have a generic form. For a polynomial, y equals a times the quantity x minus h raised to the power of n plus k. Now review, what do these things do? What does a do? What does h do? What does k do? A is something we're multiplying by. It can stretch, it can compress, it can reflect if it's negative. What does h do? H is our left or right translation. Question to you guys, why is it minus h instead of plus h? Why would they confuse us like that? And the answer to that, when it's inside the parentheses, it's before the action of the function, it's actually opposite. So for example, if you had x minus 2, it's actually going 2 to the right. If you had x plus 2, it's actually going 2 to the left. It's a pre-function translation. So it's before the action of the function, before the squared or the cubed. And then plus k, that moves it up or down. After the function's action has occurred, so after you've subtracted h, after you've multiplied by a, then you add k, that's just going to either move it up or down depending on k's value. Just a review of translations, we've been talking about those throughout the book. Reflections, we've been talking about those throughout the book. Let's take a look at one. So we have y is equal to negative 3 times the quantity x plus 2 squared. We want to sketch the graph labeling the x-intercepts and the y-intercepts. Give you a second to copy that one down. First question to ask yourself tonight, out of our power functions, which power function is this most closely related to? We see the power on this is squared. So our base one that we're going to start out with, a parabola, y equals x squared. We're multiplying that by negative 3. So we're going to start with the function y equals negative 3. Or, excuse me. Change that to a squared. Pause for a sec. I want to keep that. Put a 3 where there should be a 2. Oops. Ready to go, Frank? Okay. Let's take a look at the function as an example. Y is equal to negative 3 times the quantity x plus 2 cubed. I'm going to sketch the graph, labeling the function, and we want to find the x and y intercepts for this function. So the first question we're going to ask ourselves, okay, what is our base power function for this? And for this one, our base power function, what's it most closely related to, will be x cubed, the cubic function, or x to the third power. We're multiplying that by negative 3. What's that going to do to it? Well, for sure, what's the negative going to do? It's going to reflect it through the x-axis. What's the 3 going to do? Is it going to stretch it or compress it? Okay, it's going to compress our values. So let's take a look at what that's going to do for us. Let's take a look at what that function has. We'll start out with the base function, y is equal to negative 3 times x to the third power. And then we're going to look at if there's a vertical shift, if there's a horizontal shift. So let's go to our grapher real quick and let's take a look at our base function. And let's delete all these out. And plot our new function, which will be negative 3. X to the third power. And let's plot that. Oops. So notice we had a reflection through the x-axis because on our x cubed we'd be going to infinity, so as x gets very large we're going to negative infinity. Now what's going to happen is we add in that plus 2 in the inside. Let's take a look. So the plus 2, is that going to be a vertical shift or a horizontal shift? That's going to be a horizontal shift because it's pre-function, it's before you take the cubed. Inside means you have to go opposite, so that's going to move it 2 to the left. So as we move these points, we did have an intercept at 0, 0. We're going to need to move that over 2 to the left. So our intercept's going to go from 0, 0 to negative 2, 0. So that's our first point. Let's go to the dot cam real quick. Let's look at the dot cam real quick. As we take a look at this, our x-intercept can we switch to the dot cam? Thank you. Our x-intercept originally started at 0, 0. That translation of 2 to the left moves it to negative 2, 0. And again, what's the x-intercept mean? What do you have to plug in to get 0 out for an answer? If we plug in negative 2, we have negative 2 plus 2, which gives us 0. 0 cubed is 0 times negative 3 is 0. For our y-intercept, what number will we plug in to get what number do we plug in at x equals 0 to get the answer out? So we plug in 0. 0 plus 2 gives you 2. 2 cubed is 8 times negative 3 is negative 24. So taking a brief look at our graph, let's switch back to the computer. Let's take a look at what our graph has on it, and let's plot our new function, which is y equals negative 3 times parenthesis x plus 2 to the third power. But you notice our x-intercept up here, our y-intercept's actually out. We'll have to compress our view down to see it. This is a bit darker. And yep, intercepts right there, 24. Let's put the dot in. Yep, 0, 24, 0, negative 24, where our y-intercept is. Good. Questions on that on campus here? So again, what we have in that one, we did have a small compression with the 3. We did have a reflection with that negative 3, and then we had a horizontal shift 2 to the left by the plus 2 inside the parenthesis. Last topic for today, we're going to talk about what happens near an intercept. So we're going to describe the behavior of a function as it approaches one of the intercepts. So we have a function here, f of x is equal to 2 times the quantity x plus 2 squared times the quantity x minus 3. So as you'll notice as we keep going through this book, we keep adding features to our ability to graph functions. And we originally started with just the power base, we added in some translations, we added in stretching and compressing. Now we're going to say, okay, we know that the answer, the output at negative 2 is 0. Now how do we know that? Of course, plug in negative 2. Negative 2 times 2 is 0. 0 squared is 0. Multiply that out. The point is 0. What's happening, or what does it look like as it gets really close to that point? So let's add that to our repertoire to sketching functions. So let's flip to the dot cam real quick. We know our function, f of x, is equal to 2 times the quantity x plus 2 squared times the quantity x minus 3. Give me a second to copy that down. And we want to describe the function as it approaches x equals negative 2, which we know is one of the intercepts. So in other words, what's it look like as it's getting close? So what we're going to do for this, we know what happens with this part of the function. That's going to 0. Let's see what happens with the rest of the function. What does the rest of the function look like? So let's plug in negative 2 to the other parts of the function. So 2 times the quantity x plus 2 squared times the quantity negative 2 minus 3. Negative 2 minus 3 gives us negative 5. we can combine our constants. Negative 2 times, 2 times negative 5 gives you negative 10. So what does this tell us? F of x is equal to negative 10 times the quantity x plus 2 squared. This tells us the behavior of our function as x approaches negative 2, or as x gets infinitely close to negative 2, is modeled by negative 10 times the quantity x plus 2 squared. Now, question to you, what does that look like as we go to negative 2? Positive or negative? Well, what if we plug in a point really close to 2? This is going to be going to 0. That times negative 10. Let's take a look at what that looks like on the graph. Let's go back to our graphing utility. Let's delete out our last two functions here. Let's plot a new function. And let's plot out what we have. It's negative 10 times the quantity x plus 2 squared. So what does it tell us? Our original function, what we had, what's it going to look like as it gets close? Well, this tells us, well, as we get close to negative 2, it's going to be approaching from the negative, increasing as it goes to negative 2. Then once it bounces off that, it's going to be decreasing. It's going to be going down and going towards negative infinity from that point. That's what it looks like as it approaches that function at that point. What's it look like as it goes to the intercept? So kind of putting all of the pieces that we've talked about so far in this class. We've talked about what happens as it goes to positive infinity, negative infinity. That's our end behavior. We've talked about where the intercepts are. That's where it actually crosses the x-axis. We've talked about our y-intercepts, where it intercepts the y-axis at. We've also talked about the number of turning points that it has in the function. What we added with this is, what does it look like really close to an intercept? So in other words, is it going to be coming from the positive, from the negative? What's going to happen as it goes away from that point? Is it going to be increasing? Is it going to be decreasing as it goes to that point? So in other words, what we have with that is a quadratic with a negative coefficient, which is why we have the going up, going from negative infinity, and then going to negative infinity as it goes out of that point. So again, adding to our repertoire of being able to sketch functions with this. That's our section today. Again, we talked about what is a polynomial. How would you know if a function or a expression is a polynomial? You're looking for those positive exponential values. You're looking for the coefficients that are real. In addition, we talked about how to deal with the translation like we have with other functions we talked about so far this year. And then we talked about the behavior as we go towards an intercept. In other words, what's the graph look like as we approach an intercept from the left and from the right? Thanks.